Hi and welcome to another C++ lecture. My name is David and today we will be talking about simple inputs. As you can see, we will continue programming in the same structure we were starting to build last time. If you missed that video, give it a look. It will be linked in the description below. So to make it as simple as possible, the first thing we will be needing is some kind of space we can store our data in. This is usually called a variable. There are a lot of different types of variables, but to cover them all, we probably need a whole nother video to talk about it. Everything you need to know for this video is that we will be using the integer, which is written int for integer, and give it a proper name, like just example value, for example, semicolon. So the integer type can store up to 64 bits depending on your operating system in numbers. That's very important. So what that means is that on your computer, a certain amount of space will be reserved for your integer right here. It's also very important that all your variables should have a value attached to them while created, because it actually can cause warnings and even errors depending on the compiler you're using, because nothing on your computer, no memory, is ever really empty. Meaning I'm seeing a lot of people including different variables into the program without using the definition right here, giving them a proper value, and just assuming that it's always 0 because they didn't change the value to something else. But in fact, inside the variables, there are often some different kinds of values depending on what other program was using this memory at some earlier time. So to continue with the program, let's just make a small output, something like please enter a number, semicolon, and type in, instead of cout, cin. Use the brackets facing right, not left. Right is always for input and left for output. And just use the example value here. Whoops, forgot to copy. So sorry. Let's try this again. End this with a semicolon. And maybe even output the number you chose is, and now including the number again, we're using the brackets pointing left, and just type in the example value and it will be highlighted, making it much easier to see what you're using and where it's maybe changed or not. Using the end line, maybe even including the end line right here again, just to have it nicely written. Let's try or test our program. We will now have to enter a number. Let's use the 10. And you will see the number you chose is 10. So everything went as planned. So basically now you found out how the input works, which is actually only this part, showing you the syntax of, okay, what do you need to write in order to enter something inside a variable you basically defined in the beginning, and to output it this way. So the critical thing here is just to see, okay, which brackets are you using, in which way are they facing, in order to make this work, basically. In addition, we can still try to see what happens if we remove the 0 up here. And you will see no error will occur, not even a warning. And let me tell you why. It's because we are not using an output of example value before entering some value inside. So basically what I'm hoping or guessing is that if I'm trying to output the example value before entering any value, it will probably give us an error. So let's just copy this to make it a bit faster. Let's just build it, and you will see an error occurs. And that's what I was talking about earlier, because it tells you, okay, sorry, this is German, but it basically tells you it's not initialized and we are using a non-initialized variable. So some of you may argue and say, okay, that's a non-good compiler if it does not want to run your program, because basically the output of a value which is not initialized should like give you some data which is not 0 or null, whatever, which is still basically stored inside this example value from some value it got from another program before. But the problem, if your compiler is only giving you a warning, is that of course your program is perfectly running, basically. Well, not perfectly, but it does not punish bad programming language, or in other words, a bad programming style. The problem is that a lot of students, even in universities, have the tendency to ignore warnings because the program is basically running, so why change anything as far as the output is correct? And the problem with that is that at some point this will catch up with you. With every warning there is like a little guy in your compiler telling you, hey, this can basically go very, very wrong at some point, and you must not ignore any warning given to you. I mean, it's like being on a highway and losing one of your tires, and your computer tells you, hey dude, there's one tire missing, but you're like, okay, we're still driving, so this isn't any problem. So I think I talked about everything I wanted to talk about, and to show you as simple as possible what you can do with the simple inputs. If you have any questions, don't hesitate, use the comment section below. And if you have any wishes for the next videos and topics you wanted to talk about, or wanted to see videos about, just let me know. And yeah, have a pleasant day, and we'll see each other next time. Take care and bye bye.